It's the Innovation Stream and I'm here with Jon Powell, Capability Lead. We're going to be discussing the manufacturing process within healthcare. Now, Jon, we don't necessarily think about the last stage in the process, the manufacturing.
It's really important to start thinking about manufacturing really early on in the process. So when you're coming up with the initial concepts, having that view for the end phases will make your journey there much simpler in the long term. When you make a mistake in the late phases because you haven't thought through the process, it becomes very expensive and sucks up a lot of time.
And we've been living in quite interesting times recently, where there's been uncertainty because of the pandemic, but also because of the geopolitical landscape. How are we seeing? Are we seeing any impact on manufacturing?
Huge impact, and I think the impact's going to last with us for many years to come. So COVID's had a big disruption both to our daily lives, but also to the supply chain. So you might have heard about chip shortages. So car manufacturers are really struggling to find the chips that they need to run the complex electronics inside automotive vehicles. But that floods all the way through the electronics world. So connected devices have those sorts of challenges as well. The inventory for those products is so much lower now that the big players in the market are buying up huge amount of production space. So using a design consultancy to try and do something agile and fast in that space means we have to come up with new routes to help our clients get to market. So it's certainly challenging.
So it's almost like you need a method or a manufacturing process A plus backup B and C for each aspect within the
Ideally,
process? You
want second sourcing. You want a supply chain that has some redundancy in place, or at least has the concept in mind. So if you're single source only, then you're naturally at risk. So where backups for different plastic resin suppliers, for example, that you might have qualified 2 or 3 different material choices, and it might be the same generic grade, but if it comes from a different manufacturing plant, it can actually have different material properties, and within some designs that can be very sensitive. So
again, is looking at that manufacturing process early on in the process of your designing the product.
Exactly. So we really love to get our manufacturing engineers in those early brainstorms, in those the concept design review steps of the process before the product is even really designed. It doesn't even exist conceptually. It's that white blank space. If you're then already thinking about how it's going to be made, you can down select ideas, you can rule out avenues that might initially look promising, but ultimately if you can't make the product, if you can't produce it at scale, you don't have the opportunity to really bring that design to life. You can take it all the way to the point of launch, but if ultimately it's not a real product until it's on the market.
So it's building resilience into the manufacturing process. And we were touching earlier on kind of the pandemic having an impact on global supply chains. Have you seen a move towards more localized manufacturing processes?
There's definitely a shift to moving to more domestic manufacturing. At least you saw during the pandemic that companies were switching their manufacturing lines to produce PPE, for example, whereas previously that would have always come from low-cost economy countries. Because there was an urgency, the supply chain was cut, we needed to do something local. That sort of mindset and mentality is definitely coming back, I think, into manufacturing, and the consideration of multiple routes to make it a more resilient, reliable source of production is definitely a conversation.
There was quite a lot of excitement around the idea of 3D printing when it first came out. Is it still as exciting within manufacturing for healthcare?
I certainly think so. It's certainly got a key part to play. This morning I was handling some 3D parts, and it was great to be able to see something I've had on the computer screen and actually now have them in my hand and be able to see how they interact. But the parts, they're not always representative of the finished materials. So some of the challenge you might not consider is the friction, how the parts go together. They might not quite feel or clip or as you would expect with the final materials. So you gain massively in terms of speed and the iterations you can do in the sort of design, build, test sort of loops. You can go through multiple iterations much quicker these days. However, you still need to get to more traditional manufacturing methods quite often when it comes to sort of large-scale production.
Are there any other kind of issues when you're trying to scale up a manufacturing process that people need to be aware of?
Yeah, so one of the challenges we see is when you have everything on screen and you can zoom in 4,000% and everything aligns normally and everything's straight and perpendicular and it's beautiful, and you can spin it and it's a wonderful tool to create designs. However, when you move into the manufacturing world and you're producing parts, you have always a normal curve. There's always a range of tolerances. No matter how good your manufacturing process will be, there'll always be slight outliers to the absolute nominal process. And that can lead to challenges with tolerances, with overlaps, with where parts might not quite fit together, and this is where techniques like 3D printing work really well. So you can get from the screen into a part in your hand, and then you can start to see where those challenges might lie. And tools and techniques like tolerance analysis, statistical analysis you can do to support the design effort help you with that manufacturing challenge.
And is there something really exciting that you've been working on recently?
Yeah, so one company I'm working with at the moment is working heavily in circulating tumour cells, which is a really interesting area of science. And these are tiny elements of the blood volume. Just to put this into perspective, the circulating tumour cell, one circulating tumour cell is surrounded by 1 million white blood cells, which is then surrounded by 1 billion red blood cells in 1 milliliter of blood. So we're looking for a needle in a haystack.
Wow, so you need an incredibly sensitive system then?
Yeah, exactly. So we're working with our clients at the moment, and they have the hardware, but they've asked us to look at the consumable for this diagnostic product. I have a sample here. So it takes the blood sample from the cancer patient, and then through valving, etc., it passes it around the system and through a tiny chip. And what this does is actually using a vortex approach, it separates out the circulating tumour cells. If you think of the way I visualise it is if you see the Olympics canoeing as they're going down the rapids, and you have pools where the water's really quite still and pools where the water's moving really fast. Very similar to here, so it separates out the circulating tumour cells using that technique, and the absolute precious sample that is retained after the process in about 40 minutes.
And there was a problem with the manufacturing process that was affecting the diagnostic capability.
Yeah, exactly. So when they asked us to look at it, they were having some challenges in production. So they had quite heavy yield issues, which meant for every 100 they were producing, they had to throw away 30 or 40 cartridges, which is obviously a very expensive process. Producing that much plastic waste as well is not good for the environment. So they came to us and said, hey, can you have a look at this? We discovered that the joining process between the two halves of the cartridges was probably not optimized. So we've moved that away from previously ultrasonic welding to a laser welded process. Mm-hmm. We've also looked at how the sample tubes are connected and how the chip is sealed. And all of that with the aim of improving the manufacturing yield, so there's a manufacturing element to it, but also the recovery rate. So of the circulating tumour cells will increase. So for every 40 ml of blood, you'll be getting just a little bit more of those precious circulating tumour cells.
And how did the manufacturing process, changing the way that it's lasered, actually increase the sensitivity?
So when you're ultrasonically welding, you get flash or tiny fronds of material that are travelling around in these blood flow channels, and those potentially can capture the cells that you're looking for as well. So you're actually retaining some in parts of the cartridge that you're not interested in. You're really trying to drive them towards that microfluidic chip.
And manufacturing is such a key component for creating innovation within the healthcare area that CDP are actually, within their new headquarters, embedding a designated manufacturing facility.
Yeah, it's fantastic. Really looking forward to moving into our own space, a manufacturing building, 2,400 square metres of manufacturing space that will be able to explore new innovations, develop processes, produce products. And within that, we'll have a clean room as well, so 100 or so square metres, Class 7 clean room, which is a controlled environment which allows us to assemble, build medical devices that can be used straight for clinical trials and for home use for real world cases.
And lastly, can you tell us one thing that's really exciting you within the area of manufacturing innovation at the moment?
Wow, there's a lot going on, and one area that we haven't touched on yet is probably in the digital space. And this is it's been talked about for a long time. Industry 4.0 has been talked in the manufacturing world for a long period of time, and we're now even talking about Industry 5.0. It's going to be really exciting to see how some of the changing methods of working that we've all adopted as part of COVID will start to be lived through those sort of strategies as they morph and change. So whether that's not needing to be present in a manufacturing site anymore, but because you've got a digital twin, so you're modelling and mapping the processes. So you've got a production line that's running in real time, and you can take all the sensor data from that, and you'll be able to model the extremes of the process. You'll be able to understand maybe where the weak points or risks are in the process. And those sorts of technologies are fascinating and exciting times.
Jon, thank you so much for your time. It's been really interesting exploring the world of manufacturing and innovation in the healthcare arena.
You're very welcome, Hannah. Great to talk to you.